So, we do number 19 here. Determine the mass of each of the following. So 0.2 or 2.345 moles of lithium chloride. Okay, so they provided me 2.345 moles of lithium chloride, and I want to go to grams of lithium chloride, correct?
Yeah, that's right.
All right. So I can see that I need my moles on the bottom of lithium chloride, and I need grams of lithium chloride on top. This is the what's called the molar mass. I'll search that on Google. Molar mass of lithium chloride. It's 42.39 grams of lithium chloride for every 1 mole. So 2.345 times the 42.39. Okay, times 42.39. So a 99.4 is our answer for the grams of lithium chloride there. Moles of acetylene, 0.0872. You can see the pattern, right? You take the moles and times its molar mass, because that's how many grams there are per mole, and that'll give you how many grams, right? So I find the molar mass for acetylene. Molar mass for acetylene.
The molar mass of acetylene is 26.04 grams per mole.
So 26.04 times my moles that they provide, 0.0872.
And that has three significant figures, right?
Yeah, so 2.27 would be our answer for B there. All right, C, 3.3 times 10 to the minus 2 moles of sodium carbonate. Now, here's how I write that in my significant figures, or my scientific notation, 3.3 times 10 to the minus 2. All right, so that's moles, and now I'm going to multiply it by 106, is that what it is? Molar mass of sodium carbonate.
The molar mass of sodium carbonate is 105.99 grams per mole.
106 grams per mole. Okay, so times 106. Okay, so 3.5, two significant digits, 3.5 for the grams of sodium carbonate. All right, fructose, 1.23 times 10 to the 3 moles of fructose. Molar mass of fructose here. Molar mass of fructose. Molar mass of fructose. 180.
The molar mass of fructose is 180.16 grams per mole.
Okay, so 220,000. Oh, 4 significant digits. So 221,600 grams of fructose.
What's that in scientific notation?
That's a good point. 2.2, we want 4 significant digits, 2.217 times 10 to the, not to go from here to what there, I want 1, 2, 3, 4, 5, and that's grams of my fructose. All right, that thing there, do you know what that thing's called?
No, I'm not sure what it's called.
Well, it's iron sulfate, you see that?
Yeah, I see that.
And then they have heptahydrate. Heptahydrate. So let's see if we can get our Google to tell us the molar mass of that. Iron sulfate heptahydrate.
According to PubChem, iron, 2+, sulfate heptahydrate is a hydrate that is the heptahydrate form of iron, 2.
So 1, 2, 3, 4, 5, 6, 7. So this should be it. Iron 2 sulfate heptahydrate. So it's molar mass. Does it say the molar mass? Probably in here somewhere, but I'm not seeing it. You see it?
No, I don't see it.
There it is, 278.02.
Oh, okay.
So 278.02 times 0.5758. Okay, so four significant digits, yeah. So 160.1 grams of the iron sulfate. Okay, good. So that was number 19. Number 20. The approximate minimum daily requirement for the amino acid leucine is 1.1 grams. What's this requirement in moles? So I go to my Google here. Molar mass of leucine. Molar mass of leucine. There we
The
go.
molar mass of leucine is 131.17 grams per mole.
131.17. Get the paper out of the way. Oops. Well, LEU, leucine. And then
We got 1.1 grams.
okay, so we got 1.1 grams, and we want to know what is this requirement in moles. So 1.1 grams of this stuff, and we want to know what it is in moles. All right, so I need my grams down below and my moles up top. For every mole, there's 131.17. So 1.1 divided by 131.17. So 0.0083, 84, because we have only two significant figures, so 8.4 times 10 to the 1, 2, 3, minus 3, and that's moles of leucine, or leucine, depending on how you pronounce it. Okay, 21, determine the mass in grams of each of the following. 0.6 moles of oxygen atoms. A mole of oxygen atoms, I know what that is. That's 16, right?
Yeah.
So I just do 16 times 0.6, right? So that's 9.6. 0.6 moles of that stuff, that's twice as much grams. So that would be 9.6 times 2, because that's 0.6 times 32. This would be 0.6 times 48, right? So determine the mass in grams of each of the following. You would take this moles, so again, back to what we're doing all the time here. Change our paper out. I would like to know how many grams of oxygen there are. If I have 0.6 moles of oxygen, and 1 mole of oxygen is 16 grams of oxygen. That's on our periodic table, right? Let's bring up our periodic table here. I got a new and improved periodic table. I like it a lot better because it's nice and easy to see. We have 16 grams on our periodic table for oxygen. All right, and that's how we're going to determine that there. If we wanted to do O2, oxygen gas, right, I have 0.6 moles of O2. That's 1 mole of O2 is 32 grams of O2, right? So grams of O2 then would be 0.6 times 32. And I would do 48 times 0.6 for the other one. So those are the different masses of oxygen that I would have. Okay. So a 55 kilogram woman has that many moles of hemoglobin in her blood. How many hemoglobin molecules is this? And what is the quantity in grams? Okay. So, 7.5 times 10 to the third moles.
-3.
Oh, 7.5 times 10 to the minus 3 moles of hemoglobin. Okay. And what do I want to know?
The grams?
Okay. Or I want molecules.
Oh yeah, molecules.
I also want grams. That's the second question, is how many grams. But I would like to know the number of molecules. Well, if that's how many moles I have, now this is where it can be kind of confusing, because how molecules of hemoglobin and moles of hemoglobin relate to each other can be confusing. What you want to do is, when it gets confusing like that, replace this moles of hemoglobin with dozens of hemoglobin. And then you think about how, if you were to say I had this many dozens, how many do I actually have? You'd want to get this value and multiply it by 12, right? So if this is how many moles of the stuff I have, I know that every mole of hemoglobin has 6.02 times 10 to the 23rd molecules of hemoglobin. Okay? So, if I want molecules of hemoglobin, I'm going to have to take this, times it by how many things there are in a mole. All right? So 7.5 times 10 to the -3 times 6.02 times 10 to the 23. That should give me my answer. See, did I do that right? 7.5 times 10 to the -3, 6.02 times 10 to the 23. Yeah. So 4.5, two significant digits, times 10 to the 21. That's the molecules of hemoglobin. Now, if I wanted to go to grams of hemoglobin, I start with my 7.5 times 10 to the -3 moles. What do I have to do this time?
You need the molar mass.
That's right, and they gave it to us.
64,456.
That's right, there's 64,456 grams of hemoglobin for every 1 mole of hemoglobin. Okay? So now I just take that value times that, and that tells me how many moles of hemoglobin I have. So this times my 64,446. 64,456. Okay. So 483, two significant digits, 480 grams of hemoglobin in that many moles of hemoglobin. Okay, good. 22? No, 23. Determine the number of atoms and the mass of zirconium, silicon, and oxygen found in that many moles of zircon. So if I have that many moles of zircon, 0.3384, zircon is what?
ZrCSiO4?
Okay, so zirconium silicate, SiO4. All right. So we have zirconium silicate here, and I'm going to determine how many, let's see, determine the number of atoms and the mass of zirconium silicate found in that many moles. So if that many moles, I can determine the mass by getting the molar mass down here.